All right. Hello, everyone. Good morning still. Yeah, morning. I had to think about it for a second, having 2 morning classes. And then y'all for the 3rd. So welcome back to MDE 61. Before we begin today, I want to point out that I am starting to add some of those smaller assignments. I'm not going to add a ton as the semester progresses, but I will add more initially as we're covering the chapter P material. Let's just show you what I'm referring to there. So when you go to your homework in the MDE 61 course now, you'll notice at the top there are 2 additional homeworks. These do not have any kind of prerequisite quiz. These are much, much shorter. So remember, these chapter 1 skills review things are like 100 questions each. These are going to be 10, 15, 20 questions each in general. Trying to keep it in the 10 to 12 range. These are going to be the assignments that I say you need to get a 70 or higher on to continue to stay in this course. And then you have, while there are technically no due dates, you will have basically a couple weeks to get them that 70 or higher. It's not really going to be an issue at first, but it's more like when we're 7, 8 weeks in, if I notice you've only done 1 or 2 of these things, that's when I'm going to withdraw you for lack of participation. So again, I wanted to have something shorter for you to be able to tackle, and these will go more along, at least initially, more along the lines of what we're doing together in class. So we have covered P2 entirely. We have covered P3 entirely. P2 was the exponent rules. P3 was the radical rules. And now we're working on, we did P4 last time as well. I just haven't had time to create a homework section. I think I told y'all I have 21 credits this semester, which is absolutely bonkers. Never done it before. Not sure why it landed on my plate, but it is what it is, and we deal with things. And I don't mind it. It's just, it keeps me busy. I'm fine being busy. I'm just busy. So I will make one for P4. I will make one for P5, which is what we were covering at the end of last class. We will cover more of today. We'll probably be covering it more of next time. It takes a long time to have a nice, slow, steady boil discussion of factoring. The factoring one might be a little longer. That one might be closer to 20 questions just so you can get some good practice, but we'll see. So again, just start working on these, focus more on those initially, but I'm not saying to not do the skills 1 review homework, the skills 2 review homework and all that stuff. I would like for you to do those as well, but those are not going to be the assignments that I gauge your participation and attendance based on. But most of you will probably need the additional work so you can go to those. And they're kind of all over the place, honestly. When you look at the chapter 4 stuff, it's got stuff from chapter 1, chapter 2, chapter 3 in it. So it's going to have you reviewing things and then doing new things and then reviewing things. And you're going to see a lot of the same stuff over and over and over. So I just figured it might be nice to have more normalized homework assignments. So again, anything that says skills review, those are the ones that you should do for your own knowledge, but it's the ones that will be at the top moving forward with shorter names like P-2 homework, P-3 homework. Those are the ones you will be required to do. And what I mean required is get a 70 or higher. Now, if you get a 68, am I going to say you didn't do it? No. If I see all of them are 68s, I'm going to go, you're being slick. Come on now, do one more question on some of these. But it's, you know, oh, you got a bunch of 50s. Not good enough. Oh, you got some 30s and some 40s and some 50s and some 62s. Not good enough. Let's see 80s, let's see 90s, let's see 70s, let's see 100s. Okay. And then remember, for the skills review ones, you have to do the quizzes first to actually access them. The emphasis on the wrong syllable, maybe. Okay, so what did we do last time? We talked about generalized polynomials, some basic definitions, some of which will be very important moving forward, like the degree of a polynomial, words like coefficients. We'll be using those words a lot throughout the semester. Combining like terms, multiplying polynomials, whether it was just distributing, FOILing, or distributing multiple terms, like in that E example. Binomial squares like f and g that you have to write the parentheses times itself, not just square the individual terms. It doesn't work that way. And then we started a nice slow introduction of factoring, specifically factoring binomials, where we had a squared minus b squared equals a plus b times a minus b. We said this is a formula you have to memorize. Conversely, if you had a plus between them, you can't factor them using real numbers. We talked about imaginary numbers in today's 161 class. So that kind of gives you a hint that maybe you can factor them using imaginary numbers, something we'll see much later in the 161 semester, and something that we don't do a lot of either, honestly. So it's not going to be that huge of a deal. But you have to have this formula memorized. And then after we do one or two more examples, we're going to introduce two new formulas, a way to memorize these crazier formulas, and then some examples of those. So we did several examples factoring difference of squares. We saw one that wasn't a difference of squares, we call it prime. Then we talked about GCFs, greatest common factors, how it's the biggest thing you can take from all the terms. In terms of numbers, it's the biggest number that divides into them. In terms of variables, it's the least that you see. You can't always take a number, you can't always take a variable. But we said that sometimes you might have a difference of squares, but you can't tell it's a difference of squares because you got to take a GCF out first. So let's try that out. So go to my other folder. And let's say, example 1. I could just say factor. I'm just kind of giving you a hint here. And let's say we had 7x cubed minus 28x. So a lot of people are going to go, oh, that's a binomial. So we saw the difference of squares formula. Let's try and think of what an a and what a b are, that when you square them, you get 7x cubed, and when you square them, you get 28x. What the heck? Nah, Mr. Beckner, this is prime. You're messing with me. Not quite. So remember, take a GCF first if you ever have a GCF, and you definitely have a GCF here. You have a GCF of, well, for the numbers 7 and 28, you can take out a 7 from both of those. And for the variables, we have an x cubed and an x to the first. They both have an x, so we can take a single x out. I can't take 2 or 3 x's out because this one doesn't have a 2 or a 3. You can't take something that isn't there. So we take the GCF out, we open a parentheses, and then we divide each of these by that GCF to figure out what goes inside. 7x cubed divided by 7x is going to be x squared. Remember, if you don't trust this, multiply it back together and you should get the original. 7x times x squared is 7x cubed. Good. Minus. 28 divided by 7 is 4. X divided by x, they just cancel, and you're left with that. Don't trust it. 7x times 4 is 28x. So we have our GCF out, but that's not all we can do with this problem, because now in the parentheses here, x squared minus 4, that's a difference of squares. So we can say that the a for that formula would be x, and the b in that formula would be 2. Leave the GCF in the front, open a pair of parentheses, and then it goes a plus b times a minus b. So x plus 2 times x minus 2. And that's as far as you can take it. There we go. Let's try another one of these. That's 12x cubed y minus 75xy cubed. Once again, if you just try and do a difference of squares, well, these exponents are 3s, and that's not a good sign. 12 and 75, kind of hard to take a square root of. So there's probably a GCF here. Doesn't have to be. It could be prime, but it's not. Between 12 and 75, 3 will go into both of those. That's the biggest number you can take. Between x cubed y and xy cubed, you can actually take an x and a y. No exponents on either of them, because there's only a single x in the second one, so that's the most x's you can take. And there's only a single y in the first one, so that's the most y's you can take. If that x wasn't in the second one, I couldn't take any x's. 3x, y, parentheses, now divide. 12 divided by 3 is 4. X cubed divided by x is x squared. Y divided by y cancels. Minus 75 divided by 3 is 25. X divided by x cancels. Y cubed divided by y is y squared. And look at that. Now we have a difference of squares. Think about the numbers and the variables independently. Leave the GCF in the front alone. 4x squared, the thing that you would square to get that is 2x. 25y squared, you would need 5y squared. Both of those parts squared to get 25y squared. Giving us a final answer of leave the GCF, pair parentheses, and then a plus b, a minus b. You want the minus first, be my guest. As long as one's a plus and one's a minus. One more. Let's get weird with it. X to the fourth minus 81. Oh, so this is probably a GCF first, right? I see what you're doing, Mr. Beckner. GCF. Actually, no. There is no GCF here. There are no x's with the 81, so you can't take any x's. There's no numbers bigger than 1 with the x to the fourth, so you can't take any numbers. There is no GCF. Uh-oh. Well, maybe it's just a difference of squares. Ah, now you're thinking. It is a difference of squares. Mr. Beckner is exponents of 4, not a 2. That's perfectly fine. As long as it's even, there's a chance. So you're saying there's a chance. So what are the a's and the b's going to be? What squared would make x to the fourth? What squared would make x to the fourth? Because if I just say it's x, when you square x, it sounds redundant, you get x squared. So that's too small. Well, the next thing logically to try would be x squared. And if you square x squared, 2 times 2 is 4, you get x to the fourth. How about 81? What squared is 81? Well, 9. That's easy. So what we get here is x squared plus 9 times x squared minus 9. And a lot of people will stop here. Say this is the answer. And if they say this is the answer, it's wrong. This is a factored form, but it's not completely factored. It's not factored as much as possible. And that's because one of these two parentheses is another difference of squares. And we can factor a difference of squares. These things can happen. Does it happen a lot? No. Does it happen sometimes? Yes. Now, I'm going to circle this, but I'm going to erase the circle after a minute. X squared plus 9. That's the thing we mentioned previously, that when it's a plus, it's prime. You cannot factor x squared plus 9. So we're going to get to leave the first parentheses alone. We're going to get to leave the first parentheses alone. So I'm just going to go ahead and bring it down. This was the first parentheses. You can't factor it because that's a plus. But for the second parentheses, x squared minus 9, for this parentheses, your a would be x, and your b is 3. X squared is x squared, 3 squared is 9. So if that second parentheses, I can make this 2 parentheses and go a plus b, a minus b. X plus 3 times x minus 3. That is completely factored. So when you see x squareds or y squareds in a factored form, it means maybe, maybe it's a difference of squares if it's just 2 things being subtracted. Maybe. It's not a guarantee, maybe. So we've done a decent amount of difference of squares. I think it's time to move on to the sum and difference of cubes. Here, my scrolling code. Now I'm going to give you 2 formulas at once. I thought I was going to give you two formulas at once. Where'd the other go? Well, don't write that first. I just pasted it incorrectly, but I can fix it really quickly. Sum of cubes. Make that a plus and a minus. So copy paste. Two formulas for the price of one. So while for the squares, there's only a difference of squares, there is no sum of squares for us using real numbers. There are formulas for both the sum and difference of cubes. So if you think you've got two things being cubed, whether they're added or subtracted, there is a formula for it. So something like x cubed plus 27, or x cubed minus 125, or x cubed minus y cubed. And these are the two formulas. And yeah, they're a little hairier than the difference of squares formula. But I'm going to give you a helpful way to remember these, because I remember learning this in Algebra 2 and going, this kind of sucks. A plus B, A minus, how do I keep all this in tow? Well, look at the right side of both of these formulas. Look at the A's and B's. They're exactly the same. No matter which one you have, the A-B pattern goes A, B, A squared, AB, B squared. A, B, A squared, AB, B squared. No matter whether it's a sum or a difference, it goes A, B, A squared, AB, B squared. So that's convenient at least. So you do have to memorize the AB pattern. A, B, A squared, AB, B squared. A, B, A squared, AB, B squared. How do you memorize things? I don't know. Figure it out. Maybe you write it 50 times and that's how you memorize things. Maybe you say it 50 times and that's how you memorize things. Maybe you do examples 50 times and that's how you memorize things. You have to know how you learn. I can't tell you how you learn. But you will have to have these memorized all semester. If you're going on to any form of calculus, you will have to have those memorized all semester of calculus. No calculus teacher is going to give you factoring formulas. This is supposed to be like doing 2 plus 3 by the time you're in calculus. Okay, so no matter whether it was a plus or a minus, AB, A squared, AB, B squared. What about the signs? Well, I bet you never thought that your math teacher was going to teach you how to use soap. No, not the kind you wash yourself with. Another one of those abbreviations like FOIL, first, outer, inner, last. SOAP stands for same, opposite, always positive. It tells you the order of the signs in the formula based on the original sign. So if the first sign is a plus, I'm sorry, if the original sign is a plus, that means the first sign in the formula is a plus. If the original sign is a minus, that means the first sign is a minus. Keep doing that too much. The second sign is always opposite the first sign. So if the first sign is a plus, the second sign's a minus. If the first sign's a minus, the second sign's a plus. The last sign is AP, always positive. No matter what, it's always positive. So same, opposite, always positive. Same, opposite, always positive. This has nothing to do with difference of squares. This has nothing to do with anything else in math. It's just a cool mnemonic device for the sum and difference of cubes formulas. That way you can memorize both of them in one pass. AB, A squared, AB, B squared. So boom, done. These don't pop up nearly as much as difference of squares, admittedly, but they do pop up enough to make you lose points on tests now and in the future if you don't memorize them. Example 2. I mentioned x cubed minus 27. Let's do x cubed minus 27. Now, oh, it's a binomial. How do I tell whether I use the squares formula or the cubes formula? Easy as pie. Is the exponent divisible by 2 or 3? That tells you how. Well, that's a 3, so it's definitely a cube. Don't use squares on this. Also, there's no square root of 27. That's a whole number, so that wouldn't work clearly. There's no GCF here. So cube seems to be the way to go. Not the minus. So I still suggest that you write your A and your B first off. Or anything else, what cubed would make the x cubed? And then what, if you cubed it, would make 27? Well, it's always pretty easy when it's the lowest exponent possible. It's x. If you cube x, you get x cubed. Now, what number, if you were to cube it, would give you 27? In other words, I'm asking, what is the cube root of 27? It's 3. 3 times 3 is 9. 9 times 3 is 27. Remember, cube roots mean multiply it by itself. So there's 3 of them. Multiply it by itself by itself. All right. So a binomial and then a trinomial. Leave more space in the second parenthesis. A, B, A squared, AB, B squared. I'm not going to write the pluses and minuses at all initially. I'm just going to do the A, the B, the A squared, AB, B squared. The A is x, the B is 3. Then A squared, which would be x squared. The A times the B, which is x times 3, and yes, I will rearrange that. And then the B squared, which is 3 squared. It's only now that I'm going to throw the signs in. So same, opposite, always positive. The original sign was a minus. That's what we're basing everything off of. So this first one will be the same, so it's a minus. The next one will be the opposite, so it's a plus. And the third one is always positive, no matter what. From here, we just cleaned it up. X minus 3 times x squared plus, let's make that a 3x, and plus 3 squared is 9. Now you might think, oh, the second parentheses, that's a trinomial. We can factor it, maybe. Actually, never. The nice thing about these formulas is that that trinomial is never factorable except about 1 in a million times, and you'll never see that in this course or 161 or calculus. Unless you're doing a super, super advanced calculus. And honestly, you wouldn't even have a reason to factor it probably. Back to the blue. A, B, A squared, A, B, B squared. So, same, so minus, opposite, so plus, third, always positive. Let's do 8x to the third plus 125 y to the third. I see exponents that are 3s, so let's try a cube formula. Oh, it's a plus, it's prime, Mr. Beck. Nope. There is a sum of cubes formula. Just no sum of squares formula. So A, think about the number and the variable separately. And cube roots are a little tougher, but that's all we're doing here. Cube root of 8 is 2, because 2 times 2 is 4, times 2 is 8. Cube root of x cubed is x. X times itself is x cubed. So that's our A. For B, 120, maybe it's 3. Well, we said 3 times 3 times 3 is 27, so definitely not. Maybe it's 4. 4 times 4 is 16. 16 times 4 is 64. Nope, it's not 4. How about 5? 5 times 5 is 25. 25 times 5 is 125. So it's 5. And for the y cubed, hopefully it's obvious that y, when you cube it, gives you y cubed. Formula time. Binomial. Let me give myself a little more room. Binomial, trinomial. What's that pattern? A, B, A squared, AB, B squared. I'm not putting 8x cubed anywhere in here. I'm not putting 125y cubed in here. We're using these things, the broken down things, the simpler things. Those are the A's and B's. So A is 2x. B is 5y. A squared what I'm about to write is wrong. I'll pull out the red for a second for wrong. Red right now means wrong. This is wrong. This is not a squared. This is not a squared. This is not a squared. Because the a has two pieces that need to be squared, both the 2 and the x. So in order to make sure that happens, you actually need to wrap it in parentheses, an extra parentheses. That is the a squared. Then the a times the b would be 2x times 5y. Similarly, the b squared is going to need an extra parentheses, so 5y squared. Now the signs. So same opposite, always positive. The original sign is plus. This is what we're using for so. So same, positive. Opposite, negative. Third, always positive. Let's clean this up. 2x plus 5y, the first parentheses, generally nothing's going to happen. Second parentheses. When you square the 2 and the x, you're given the 2 to both parts. That's going to make a 4x squared. Minus 2 times 5 is 10. Leave the x and the y alone. 5y all being squared gives us a plus 25y squared. That is our answer. About 2x to the fourth plus 128x. Well, that exponent's a 4, so you might think, oh, difference of squares. But then you see a plus, you say, oh, nope, it's prime. I don't know. I don't know square roots of either of these things. I don't know cube roots of either of these things. So this is a little wacky. Well, what did we say before? Always look for a GCF whenever you start factoring anything. There's definitely a GCF here. 2 goes into both 2 and 128. And x will go into both x to the fourth and x. We can actually pop a GCF out of this first thing. 2x to the fourth divided by 2x will leave us with x to the third inside, then a plus. Half of 128 is 64. Take the x away, and you're left with x cubed plus 64. Ah, there's a 3 exponent, so this is probably a cubes. Yep, I know we can do a cube root of 64. I even mentioned it earlier. I'm going to give you all a few minutes to try this one on your own to finish it. Just make sure that when you have your answer, that you leave the 2x in the front. That has to come with you the whole way. It's just going to be 2x and then your series of parentheses. Try that for a few minutes. All right. So you do your formula. You should have got your A as an X and your B is a 4. So leave your 2x alone. You'll go AB, so x 4, a squared, which is x squared, your a times your b, which would be x times your 4, and then your b squared, which is 4 squared. Throw your signs in, your SOAP, same opposite, always positive. So plus, that was a plus, opposites are minus, always positive. And then just clean up and you'll get 2x, parentheses, x plus 4, x squared minus 4x plus 16. And there will be your answer. Give me 1 minute, sorry. Da, 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 da. All right, so I just had to do some copy pasting and get it right this time. So we've worked on enough with the binomials, the two-term polynomials. Let's start trying the trinomials. And I think today we'll just stick with the simpler ones where the leading coefficient is a 1. So factoring something like x squared plus bx plus c, where the b and c are numbers. So something like x squared plus 2x plus 3, or x squared minus 7x plus 11. Neither of those examples are factorable. I'm just giving you an idea. These don't have to be pluses. They can be minuses. They can both be minuses. They can be a mix and a match. It doesn't matter. So I'm going to give you something called the shortcut method. And it's a shortcut of something known as the AC method. And I say below, but we'll get to that another day. Is this the only factoring method? No. You've got the push and pull method. You've got the box method. You've got other things I don't even know the names of. You can pull the stuff out of thin air and hope for the best. You've got trial and error. I really like the shortcut method. I think it's the most efficient. If you've got a method that you already know, use it. I don't care how you factor. I care that you can factor. If you go to Purple Math, or if you go to Khan Academy and they teach you a different factoring method and you understand it, or something on YouTube and you understand it, use it. I don't care. If it works for you, it works for you. So what is this 3-step process? First, list the pair of numbers that multiply to make the number at the end, the C, the constant. So list all pairs of numbers that multiply to make the constant. So let's just kind of pause on that part. This is really the first step, the first half of the first step. List all the pairs of numbers that multiply to make the constant. For example, if you had a 6, you'd say 1 times 6 and 2 times 3. But in addition to that, you're trying to find out which of those pairs of numbers will add or subtract to make the middle number, the number paired with the x. And this is going to be based on some signs. You would add if your constant was positive, and you would subtract if your constant was negative. There's a little bit of memorization involved here, and it all has to do with signed arithmetic, because you're going to take a pair of numbers that multiply to one thing and add or subtract to another thing. Well, if they're both negatives, they would have to add, because a negative times a negative is positive. And if they're opposites, then they'd have to subtract, because you have a positive and a negative. So first, list the pairs of numbers that make the constant. And then you're trying to find out which of those pairs either add or subtract based on the sign of the constant. Plus means add, minus means subtract, to make the middle number. Then you'll give those two numbers signs based on the adding or subtracting to the sign of the b. I know this sounds really weird without trying it out, but make sure you're writing this down because it'll make sense when once we start doing examples. Give these two numbers signs based on adding or subtracting to the appropriate sign of b. So if b was negative and you had to have the same signs, that means both, if b is negative and they had to be the same sign, they both had to add, then you're going to need two negatives. If the c was negative, that means you're subtracting, and that means the b is going to take the sign of the larger of the two numbers. Once again, trust me, it makes more sense once we see the examples. So those two numbers with their signs are going to be the magic numbers in the factored form. The factored form always goes x the number with the appropriate pluses or minus signs. I'm going to have a typed up example, but I'm going to show you how I would go through and do this. So if I told you to factor x squared plus 5x minus 6, here's what you would do. Here's what I would do. I would take this number, this constant, including its sign, and I would write it to the side. To the side, I'm going to write minus 6. And then minus is important for later. And then I do a little upside down v, which is my notation, and I write all the pairs of numbers that multiply to 6. 1 times 6, or 2 times 3. Whole numbers, specifically. No 1.5 times 4. So that's me listing the pairs of numbers that multiply to make c. I'm up to here at this point. Then we want to figure out which of these pairs, either this pair or this pair, which of those will add or subtract to make this number, this positive 5. And you might think, well, either of these work. I could do 6 minus 1, that's 5, or I could do 2 plus 3, that's 5. But this sign right here is what tells you to subtract. So because this is a minus, you have to subtract. If that had been a plus, you would have to add. So in fact, the 2 and the 3 do not work because 3 minus 2 is 1. You actually choose the 1 and the 6 because 6 minus 1 is 5. Now the question is, do you do positive 6 and negative 1 to make a positive 5, or positive 1 and negative 6 to make a negative 5? They'll have to be opposite signs in order to do a subtraction. That's the way signed math works. Again, if you're rusty, de-rust. Well, we're supposed to make a positive 5. If that's a plus, we're supposed to make a positive 5, which is why I'm going to make the choice of a negative 1 and a positive 6. I'm actually going to do this x squared, 5x, and 6 combo 4 different times with different signs and show you just how the signs can change things. So what you end up with automatically goes x in a parentheses with numbers after it. And the numbers that go after it are the circle and sign numbers here, a -1 and a +6. The order doesn't matter. I like to do it in the order C. So -1 and +6. If you don't trust this, guess what you can do? You can FOIL check. I'm not going to show that work, but it does work. I'll say it. X times x is x squared. Good. That's the first. Outer. X times 6 is positive 6x. The inner, -1 times x is -1x. 6 minus 1 is 5, so there's our 5x. And then for the last, -1 times 6 is -6. We got to example 2, so this is example 3. And here's just the written form of what I have, the typed up form of what I have above. you don't really need to write that. I think I said example 4. No, 2, 3. And if you want to see the rest of it, take a picture because I'm about to delete it because I want the instructions on the screen. 5, 4, 3, 2, 1. And you can always go to YouTube for the replay. It's also in the factoring document I gave you in Canvas in the 161 tab. Factor A, we're going to go with x squared plus 5x plus 6. So first, to the side, list the pairs of numbers that multiply to make the constant. And kind of stop here for now. Just focus on that part. List the pairs of numbers that multiply to make the constant. So that's a plus 6. Remember, the sign is important. Don't forget the sign. What's still 1 times 6 and 2 times 3? The sign comes into play now. Adding or subtracting based on the sign to make the b. Adding if it's positive, subtracting if it's negative. So since this is a plus, we need to add this time. 1 plus 6 is 7, so that's out. 2 and 3 make 5. Ooh, and that's what we're supposed to make. We're supposed to make the middle number a 5. In particular, a positive 5. How can we add 2 and 3 to make a positive 5? Well, they both have to be positives. Positive 2 plus positive 3 is positive 5. So this would go x in the first spots, plus 2 and a plus 3 in the second spot. All I did was change one sign and it changed some numbers and signs in the answer. All right, let's try another. X squared minus 5x plus 6. List the pairs of numbers that multiply to make the c, but add or subtract to make the b. So we take the constant with its sign to the side, plus 6. We're getting good at this, hopefully. 1 and 6, 2 and 3. Pick the pair that, since this is a plus, adds to make the 5. 1 plus 6 is 7, that's out. 2 plus 3 is 5, that's in. But you have to give the 2 and 3 appropriate signs to make sure that they add to a negative 5. A positive 2 and positive 3 add to positive 5. These are going to have to both be negative. If you mix the signs, the product would not make a positive 6, it would be a negative 6, because you'd be doing positive 2 times negative 3, or negative 2 times positive 3. That's it. So we get x minus 2 times x minus 3. Let's squeeze c in over here. X squared minus 5x minus 6. Let's do both negatives. So this time we're going to take a minus 6 and split it up into products. 1 times 6, 2 times 3. Because that's a minus, we will be subtracting the pairs this time. 6 minus 1 is 5, 3 minus 2 is 1. We're trying to make a 5. So we choose the 1 and the 6. We're back to the 1 and the 6. But unlike the example above, we're not trying to subtract to a positive 5. We're trying to subtract to make it a negative 5. Which means the larger number needs to be negative. So we go plus 1 and minus 6, because 1 minus 6 is negative 5. So x plus 1 times x minus 6. I'm going to change one of the numbers in here, change the 5 to a 1. I didn't write a 1, but it's implied to be a 1. because you don't see a number in front of the x. So to the side, we take the -6. This is the number you, with the sign you write to the side. 1 times 6 or 2 times 3 once again. This time we're trying to make them subtract to a +1. I don't have the 1 written there because you don't ever write it, but that means we're subtracting to try and make a 1. 6 minus 1 is 5, 3 minus 2 is 1. Boom, choose the 3 and the 2. We want to make sure they subtract to a positive though, so we go -2 and +3. So our answer, the x minus 2 times x plus 3. Factoring has tons and tons and tons of uses. It's never going to go away. You need to practice this over and 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 over until it is a part of you. And just seeing 4, you're not going to be a master at it. Just doing 4, you're not going to be a master at it. All right, let's do another. X squared minus 10x plus 24. About 2 more probably. Call it a day. To the side, we just write a 24, right? No. Write the plus because that's a reminder for later. List all the multiple pairs of 24. 1 times 24. Sorry, I was about to say 2, so I had it on my hand, so to say. 1 times 24. 2 times 12. 3 times 8. 4 times 6. Notice how I'm going in an ascending order in one column. Is that necessary? No. Is it helpful? Oh yeah, it's helpful. Because then I'd say, all right, well, 5 times 9. Well, 5 doesn't go into 24, so that doesn't work. The next one will be 6, which is 6 times 4. I already wrote 4 and 6, so I know I'm done. If I went 1 times 24, then 4 times 6, then 3 times 8, maybe I'm rushing and I miss 2 times 12 if I go out of order, especially if these are weird or wackier numbers. Now I'm trying to find the pair that adds to make a 10. Well, 1 plus 24 is 25, so that's out. 2 plus 12 is 24, so that's out. 3 plus 8 is 11, so that's out. 4 plus 6 is 10, that's the magic number. Choose the 4 and the 6. Now, what if I made it a +4 and a +6? Well, that would add to a +10, but we're supposed to make it negative, so that's not right. Maybe you mix up the signs, but if you mix up the signs, you're really subtracting them, and you'll get a 2 or a -2. To make sure these make a -10, they both need to be negative. Giving an answer, x minus 4 times x minus 6. About x squared minus 16x minus 36. We'll call it a day here when we finish this one. So to the side, write your minus 36. Split it up. 1 times 36. Does 2 go into 36? Yep, 18 times. So 2 times 18. Does 3 go into 36? Yep, 12 times. Does 4 go into 36? Yep, 9 times. Does 5 go into 36? No, so don't write 5. About 6? Yep, 6 times. Well, that's a match, so we know the next one, 7 won't work, 8 won't work, the next one would be 9. We're done. We got 5 options this time, the most we've seen. Now, be careful. Again, you're supposed to be subtracting these pairs to make your negative 16. Subtract the pairs. Don't worry about the signs initially. Just do the bigger minus smaller. 36 minus 1 is 35. That's out. I'm going to skip the one that works. 12 minus 3 is 9. Nope. 9 minus 4 is 5. Nope. 6 minus 6 is 0. But 18 minus 2 is 16. So that's our working pair. But we got to make sure they subtract to make a negative 16. We got to choose our signs appropriately. Some people will make both of them negative. Negative 2 and negative 18 make negative 20. They need to be opposite signs because they're multiplying to a negative. If you do a positive 18, 18 minus 2 is positive 16. So no, it's a positive 2 and a negative 18. X plus 2 times x minus 18. Remember, you can always FOIL these to check if you don't trust yourself. All right, so like I said, we're going to call it there. We'll do probably 1 or 2 more of these examples next time. Maybe we'll do one mixing in a GCF as well, hint, wink, nudge, spoiler alert. And then we'll introduce that more advanced trinomial technique when there is a leading coefficient that's not 1. We have what we call the AC method, the thing that this was a shortcut of. So there's more steps, there's more work, there's more involvement. In fact, I will probably do factoring a 4-term polynomial before that because the technique for that is going to be involved with the AC method. So I'm going to go what'll feel like a little bit out of order because I'm going to go from 3 terms to 4 terms and back to 3 terms, but trust me, it makes sense. Before we close out, any questions? Have you unmuted if you do have any questions, or if you want to type them? Okay, so for now, focus on that P2 and P3 homework. Again, in case you missed it, when you go into my math lab, you'll see a couple new assignments. I'm going to make a P4 and a P5 soon-ish. I might not be home for a couple of days if we do get snowmageddon. I'm going to go camp out somewhere else, not literally camping, and I won't have access to my TCC stuff. But I'm thinking by Tuesday of next week, I'll have at least 1 more of those assignments up. And remember, these are going to be the things that I say you have to get a 70 on as we progress through the course. We're going to have more of them initially and less of them eventually. So while we're specifically working on chapter P material, you're going to see these come at you sooner and quicker, but they'll come less frequently as we keep moving forward, as we're more just supporting the material from 161. All right, so stay safe, stay warm. Hopefully there's no crazy snowmageddon unless that's what you want, in which case enjoy it. And have a good weekend either way. We'll see you on Tuesday. Take care, everybody.